Hello guys, this is Edward from STEM. Today we are going to be doing revision exercise on required practical activities for A-level chemistry examination. Okay, so we're going to start with these questions, and it says this question is about white solid MHCO3 that dissolves in water and reacts with hydrochloric acid to give a salt. And this is the equation of that particular reaction here. Okay, and it says a student was asked to design an experiment to determine a value for the molecular weight of MHCO3. The student dissolved 1464 milligram of MHCO3, okay, in water and made the solution up to 250 cm cube. 25 cm cube samples of the solution were titrated with 0.102 mole per dm cube hydrochloric acid. The results are shown in the table. Okay, so we have the results of the titration in this table. Calculate the mean titer and use this to determine the amount in moles of HCl that reacted with 25 cm cube of the MHCO3 solution. Okay, so the salt basically is what is a bicarbonate. Okay, is a bicarbonate salt. Okay, because of this H, okay, CO3. All right, so now to get the titer value, so we have the rough titration. This is the first titration, second titration, and the third titration. Usually you don't make use of your rough titration, so you usually ignore the rough titration. Okay, so let's look at the first, second, and third. If you're going to use your titer value, you have to ensure that the difference between these values are not more than 0.20. Okay, the difference should not be more than 0.20. Right, so let's see the difference between 1 and 2. You can see 1 and 2, the difference is about 0.25, and between 2 and 3, the difference is about 0.1. Okay, so we're going to use 2 and 3, the value of 2 and 3, which is 9.75 and 9.65. So our mean titer value, okay, will be equal to 9.75 plus 9.65 divided by 2, and that should give us 9.7 cm cube. Okay, I hope that makes sense. Now then we also asked to calculate the amount in moles of HCl that reacted with 25 cm cube of the bicarbonate solution. Okay, so to calculate the moles of HCl, we know that concentration is equal to the moles divided by the volume in dm cube, right? The volume in dm cube, right? So therefore, if you cross multiply, your moles will be equal to the concentration multiplied by the volume. Okay, so now what is the concentration of HCl? The concentration of HCl is 0.102 mole per dm cube, so that will be 0.102 multiplied by volume. Now what's the volume? The average titer value, the mean titer value, which is 9.7 cm cube, right? So we have to convert this to dm cube, and to do that we divide by 1000. Okay, you have to divide by 1000. 9.7 divided by 1000, so we have, that's basically going to have 9.7 times 10 to the power minus 3, okay, dm cube. So if you multiply 0.102 times 9.7 times 10 to the power minus 3, so that will give us 9.8 is equal to 9.894 times 10 raised to the power minus 4 moles. Okay, so that is the moles of HCl that reacted with 25 cm cube of the bicarbonate solution. I hope that makes sense. So let's look at part B of this question. Calculate the amount in moles of MHCO3 in 250 cm cube of the solution. Then calculate the experimental value for the molecular weight of MHCO3. Give your answer to the appropriate number of significant figures. So now you're asked to calculate the number of moles, okay, in MHCO3. And for you to do that, you need to know the concentration of MHCO3 in moles per dm cube. Okay, we need to know the concentration in moles per dm cube, but we don't have that, do we? No. However, we do have the concentration of HCl. Okay, we have the concentration of HCl in moles per dm cube, right, to be equal to 0.102 moles per dm cube, right? So using this information, we can calculate the concentration of the MHCO3 in moles per dm cube. Okay, that's the first thing we're going to do. So we use this formula. We use Ca Va over Cb Vb equal to Na over Nb. Okay, now what is Ca? Ca is the concentration of the acid. Okay, Va is the volume of acid. Okay, so let me just put them here. Ca means the concentration of acid. Okay, Va means the volume of acid. Cb is the concentration of the base, so concentration of base, and Vb is the volume of the base. Right? While Na equals the number of moles. Okay, number of moles of acid. Moles of acid. While Nb means moles of base. Okay, now the moles I'm talking about here is moles from the equation. Okay, the moles from the equation. Now from the reaction of, between this between the acid and the base, MHCO3, okay, plus HCl to give us MCl plus H2O plus CO2. Now this was the equation, right? And if you can see, these are base and these are acid. What is the number of the ratio of moles? Okay, the moles of the acid and the base and the acid in this reaction. Here is 1 mole and 1 mole, so the ratio is 1 to 1. Okay, so basically number of moles of acid here is 1, and the number of moles of base here is also 1. Okay, so that is what the Na and Nb stand for. All right, so now let's put these values here. We already have our Ca to be equal to 0.102, and our Va from the mean of the theta value. Okay, that is the mean of the theta value, which is 9.7, right? So our volume of acid is 9.7 cm cube. So now we are looking for our concentration of base, right? And our volume of base is a volume 25 cm cube, right? 25 cm cube. You can see that from the question. Okay, and so our Na, which is number of moles of base of acid, sorry, number of moles of acid that reacted with the base, which is 1, is equal to 1, and our Nb, number of moles of base that reacted, is also 1. So we put all this value into this equation. So Ca is 0.102, multiplied by the volume, which is 9.7, divided by the volume. The concentration of base is what you are looking for, Cb, multiplied by the volume of the base, which is 25. Okay, now it's equal to our Na is 1 and our Nb also is 1. If you cross multiply, your Cb will be equal to 0.102 times 9.7 divided by 25. Okay, so if you multiply and divide, we are going to get 0.9894 divided by 25, and that will give us 0.0396 moles per dm cube. Now this is the concentration of the base, right? This is the concentration of the base, 0.0396 moles per dm cube. Now from here you can then calculate the number of moles, okay, of the MHCO3, which is our base. So we use our moles will be equal to what will be our moles? Moles therefore will be equal to the concentration multiplied by the volume, right, which is 0.0396 multiplied by the volume. And what is the volume? Now the volume is 25 cm cube, but this time around you have to convert it to dm cube, which is 25 divided by 1000. That will give us 0.025 dm cube. Okay, so if you multiply 0.0396 times 0.025, and that will give us 9.894 times 10 raised to the power minus 4. So that is the number of moles of MHCO3. I hope that makes sense. So let's look at the C question. Although from my research, students don't usually find this kind of question challenging in required practicals. Okay, so the questions they find most challenging are usually the calculation aspect of the required practicals. However, we are still going to go through this question. Okay, now it says the students identified use of the burette as the largest source of uncertainty in the experiment. Using the same apparatus suggests how the procedure could be improved to reduce the percentage uncertainty in using the burette. Justify your suggested improvement. Okay, so now whenever I say a question like this, okay, to reduce the percentage uncertainty in the burette, what you usually do is either you increase the concentration of the base, which is the MHCO3 in this case. And for you to increase the concentration of the base, what do you need to do? You need to increase the mass of the solid, right? So now you can either increase the mass of the solid, okay, so you can either use a larger mass of solid, okay, use a larger mass of solid MHCO3, which basically will result to higher concentration of, MHCO3. Okay, so you can say use a larger mass of MHCO3, or you say use a higher concentration of MHCO3, or you can also say you should use a dilute concentration or say a less concentrated HCl acid. Okay, less concentrated HCl, okay, acid. Now, what is the justification for this? Justification is so as to have larger volume of HCl acid during the titration. Okay, so as to have larger volume, okay, of HCl acid during titration. So this is basically the justification. Okay, so like I said, it's not very challenging to students. Okay, it's just the calculation aspect that are most challenging. So we're going to look at another calculation in the jiffy. So let's calculate the relative molecular mass or relative molecular weight of MHCO3. And we can do that by using this equation, by using this formula. Moles is equal to mass over relative molecular mass. So our relative molecular mass, MR, therefore, will be equal to mass divided by moles. Okay, so what is the mass of MaCO3? From the question, it says the student dissolved 1464 milligram. So mass is 1464 milligram. Okay, we convert it to gram by dividing by 1000. That will give us 1.464 grams. Okay, so and then our moles from our previous calculation, we got our moles to be equal to 9.894 times 10 to the power minus 4. Okay, so let's put those values into the equation here. Our relative molecular mass therefore be equal to 1.464 divided by 9.894 times 10 to the power minus 4. So if you divide this, you are going to get 1.4. So we are going to get, so let me clean this. You're going to get 1479.7. Okay, so you have to convert, you have to give an answer to the appropriate number of significant figures. So you can approximate this to be 1480. That is the value of the relative molecular mass of MHCO3. I hope that makes sense.